Okay, we are going to go ahead and get started. Um, Hello, everyone. Welcome to tonight's presentation on environmental exposure and Nebraska's water. My name is Kristen Jansen, and I am an AmeriCorps member serving with Conservation Nebraska's Common Ground program. Conservation Nebraska's mission is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address local conservation concerns. Before today's speaker, there's just a few housekeeping things that I'll go over. Your cameras will remain off and you will be muted throughout the presentation. So please type any questions that you have in the chat or the Q&A section, and we will answer those at some point during or after the presentation. This presentation will be recorded and it will be uploaded to Conservation Nebraska's YouTube page within the next couple of weeks. So if you miss any part of today's presentation, would like to revisit any part or to share it with others, you will be able to find it there. Following the presentation, we will have a very brief survey that should take only less than a minute to complete. This survey helps support programming like this one, so we appreciate you taking the time to fill those out. And if anyone in attendance is interested in speaking with a Conservation Nebraska member regarding conservation issues in Nebraska, or to find out more about what we do, I'll put our email in the chat, so feel free to reach out. So tonight we welcome Dr. Jesse Bell from the University of Nebraska Medical Center, who is going to speak to us about environmental exposure and Nebraska's water. So I will let him take it away.
Well, thank you so much. Thanks, Kristen, for having me here, and I appreciate Conservation Nebraska also inviting me to participate in this event and hosting this event. So I'm Jesse Bell. I'm faculty at the University of Nebraska Medical Center. I also have a faculty position at the University of Nebraska-Lincoln. I'm the director of our Water, Climate, and Health program, and I'm also a director at the Doherty Water for Food Global Institute. And I'll talk a little bit about these before I dive into some of the work that we've been doing, especially in the context of water quality, and human health. And so I've been here at the University of Nebraska for about 6 or 7 years. And I'm originally from Nebraska. I was born and raised in Nebraska, up in the northeast part of the state. And I came back in that, like I said, 6, 7 years ago. But before that, I was working at the Centers for Disease Control and Prevention. And I was also working at NOAA, the National Oceanic and Atmospheric Administration. And so when I first got here, a few years after I got here, we had this very fortunate opportunity to start the Water, Climate, and Health program at the University of Nebraska. And the whole premise of this program is to pioneer interdisciplinary research, education, and collaborative solutions to public health challenges that we face with water and climate here in Nebraska and around the world. And so this program, it got kicked off and we had back in 2020. And with that, we kind of realized that we needed to build it around 4 key components. Research, we're an academic research medical center. And so research is kind of our foundation of a lot of the work that we do. Education, we engage with students, we engage with other people within the University of Nebraska system and even outside the University of Nebraska system. And I'll talk about some of that work in just a bit. Engagement, and so working with people that are trying to make decisions on the ground to help them do the best decision making as possible. And then policy development, and with that, it's mostly providing good, sound scientific information so that policy and decision makers can make good decisions. And so that's kind of the 4 pillars that we build around within our program here at the University of Nebraska. And so we're housed, the Water, Climate, and Health program is housed at the University of Nebraska Medical Center. We're in the College of Public Health, although we work with different colleges and programs through the University of Nebraska Medical Center. But we're also a branch of the Doherty Water for Food Global Institute. Doherty Water for Food Global Institute, the whole premise there is how to make sure that we have water security and food security for our changing world. And they've been doing this through a variety of different ways, similar to some of the stuff that we were talking about. So like I said, they're very interested in how do we make sure we manage our water systems to improve our ability to have sustainable food systems. And they're doing that through science, policy, engaging with a variety of different stakeholders, and working on sharing knowledge and catalyzing change to help with addressing some of our water and food security issues that we're facing. And then for our program specifically around water, climate, and health, we have things that are very water focused, but we also have work that's outside of water quality as well. And so we do work around climate change, extreme heat events, which extreme heat likely kills more people in the United States than any other climate or weather related disaster, more than hurricanes, more than floods. Flooding, drought, and extreme weather. I do a lot of work, especially on drought. And then air quality and health as well, and making sure that we're monitoring air quality to help improve the health of individuals across the state of Nebraska and across the world as well. We've got a diverse team that we've been working with. This has been expanding kind of exponentially, and there's actually other people that are associated with us as well. But we have a lot of different expertise, everything from policy people, scientists that work in toxicology, epidemiology, which I'll talk about a little bit about the foundation of epidemiology in a bit. And then we also are, a number of early career researchers and data scientists, outreach and communications people as well. And so we've grown and we're continuing to grow as a program because there's a lot of work that can happen and needs to happen here in Nebraska and around the world in addressing some of these environmental challenges that we face. And we are also very committed to engaging students. Right now, we have roughly 19 students that we've been working with across the University of Nebraska. We work with everything from undergraduate students. We've even worked with high school students to Masters of Public Health students, PhD students that are doing research, medical students, you name it. We've tried to engage with them to help build our capacity, but also build an interest in these challenging areas around environmental health, climate change, water quality, etc. And we work with a number of different partners. We work across Nebraska, but we also work across the globe. And so here are just a handful of partners that we work with, trying to address some of these major challenges that we face and trying to make sure that we're providing the information and knowledge to the broader network so that they can use that information and knowledge to help with decision making as well. And I'll give you a few of our successes. One, we were a part and we're still a part of this concept called Harnessing the Heartland. And this was in partnership with NASA because we have a lot of Earth observations around the world and Earth observations that are monitoring the things that are happening here in this part of the world as well. But a lot of times there's more focus on the coastal region. So a lot of people on the East Coast and the West Coast or those states, they get a lot more focus and more resources put into them for monitoring how their environment's changing and what does that mean for their impacts. And this was the initiative that we started and it's still ongoing to try to bring together expertise and that we have here in the central part of the United States. So this was collaboration across the center states, the heartland, to try to bring this knowledge together. And then we've done things like installing air sensors across Nebraska. Some of our team works on doing a rapid needs assessment after the the tornado outbreaks that happened in this part of our state just last year. And then we also have been doing some trainings with healthcare and public health professionals in the state and throughout this region as well. And we also have been doing some engagement globally. And so if you get a chance, take a look at our annual report. You can see the work that we were doing back in 2024. Much of this is still ongoing, and actually some of it's expanding, but it's a good premise to kind of see some of the work that we're doing. And so that's a little bit about our program and helping you kind of realize that we're doing a lot of different work in a lot of different spaces and trying to help with addressing some of the challenges that we're facing here in Nebraska. And then So with that, I kind of want to transition here to talking a little bit about public health just in general and the importance of public health because we're located in the College of Public Health at the University of Nebraska Medical Center. So public health, the broadest definition is it's the science of protecting and improving the health of people and their communities. And public health does this through education, educating the public, helping them understand the threats they face, enhancing monitoring, seeing what's like actually going on, measuring and monitoring things like water quality. And we'll talk about that in a second. Contributing to public dialogue, and we'll talk about that and some of the work that we're doing around that. And then research, which is helping understand some of those threats and what does it actually mean, and looking for opportunities for interventions. So I want to bring up this guy first. And I love telling this story. So if you've ever seen me give a presentation before, I apologize because I probably talked about him. But it's a very important story in the context of public health and also in the context of epidemiology, which is a component of public health on understanding the spread of disease and why diseases occur where they do occur. And so this is John Snow. John Snow is a medical doctor in London. And so this is back in the mid 1800s. And John Snow is famous for a couple different reasons. One of the things that John Snow helped do was bring um, anesthesia into medicine. And so the first person to actually bring anesthesia just into health was a dentist from the United States. And they used ether to knock out their patients so that they could do tooth extractions. John Snow saw this, and some others did as well. They saw this and they saw that there was an opportunity to do that for when we were having people undergo surgeries. If you ever read any of the reports or watch some like old movies that talk about, or movies that talk about time period of like the 1800s or 1700s, and they talk about medicine in any capacity, you'll know how important anesthesia is today. Because not to get too graphic, but they used to just hold people down and then they would start operating, and the person was wide awake, and a lot of people would die from shock. And so John Snow, being a very inquisitive person, being a medical doctor, he realized that maybe we should be using anesthesia, things like ether, to knock out patients before we operate on them. So we should be somewhat thankful for that, um, his ability to kind of see that opportunity. But the other thing that John Snow was really famous for, and this is where the public health concept kind of builds around, is anesthesia. Or sorry, is cholera. Sorry. And so there was a very famous case of cholera that happened in the Soho region of London. And even before that, John Snow was looking at this relationship between cholera and water. And he was like, there's a relationship here in some way. But the medical establishment at the time, we didn't have like what we have, like the scientific methodologies that we follow today. Science was a little bit more loose in how it operated back then. And 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 so back then, the medical establishment kind of just said, um, this, cholera was due to air vapors. It was bad air. You breathe in bad air, and then you would get cholera. And John Snow looked at it and he was like, there's something not quite right about this. He says he thought that it was probably linked to something else, and he kind of suspected water, and he was doing some investigations. Well, then there was this big outbreak of cholera that happened in Soho. And so what you're seeing here, this map, um, is a Soho region of London. And each of these little black marks is an indication of somebody that contracted cholera, and most died within this region. So you can see that a lot of these little households had multiple cases of cholera present in them. So he went through and he was doing this investigation, and one of the things that he was interested in was trying to link it back to where these cases occurred and trying to map it out, but also trying to figure out like what was going on. And so he did an investigation of where they were getting their water, which pathways they were taking through the street. And one of the things that he was able to find is that all these households were getting their water from this central pump. And so he was able to suspect that that pump was likely the result of that cholera outbreak. Well, so, so he put this concept forward. It became the fascinating part about this, just to kind of step back for a second, this is before germ theory. So we didn't understand germs, how they worked. Not only did we not understand how germs worked, we also couldn't look at things through microscopes. Microscopes hadn't even been invented at this point. And so there was no way of really identifying what was in water and whether or not that could be a potential hazard in some way. And so he put his thesis forward, and it was a kind of a controversial thesis as well. And there's a story here. There's a pump, and there's a replica that you can still go see in Soho region of London. I've actually got to go look at it. And there's like an entire John Snow day where they put a pump handle on and they take the pump handle off, and it's a whole process that they go through. And the whole premise behind that is at that time, they said this water is probably contaminated. So John Snow was able to convince the people to take the pump handle off so people weren't using that water because they were potentially getting cholera. Cholera is a horrible disease. If you're not familiar with it, it basically it causes you to just flush almost all the water out of your system. This disease will cause you to flush all the water out of your system. As you can kind of imagine how that potentially happens. And so a lot of people die of dehydration very quickly because of contracting cholera. Well, and so, yeah, it ended up being a whole thing. And then they took the pump handle off. People were like, where's our water? They put the pump handle back on, and it became this complex thing. Well, that's one part of this story. And, it's the first time that anybody ever used maps to look at disease outbreak and trying to trace back the origin of a disease. The other part of this story that sometimes doesn't get told is this individual that you'll see on this page here, and that's Reverend Whitehead. And so there were a lot of skeptics at the time, and Reverend Whitehead was one of them. He was a reverend that served that community. And he told John Snow, he's like, I don't think you're right. I think it's air vapors. It's what, the medical establishment has said. So Dr. Snow shows up with his thesis. He's like, this is what I've been looking into and researching. And Reverend Whitehead reads it and he says, I think you're right, actually. I think you're right. And because of that, Reverend Whitehead, because he was a known figure within the community, he helped John Snow get into those households and identify who was getting sick and who wasn't getting sick, but also identifying where the potential origins of that disease occurred. And it actually, they were able to trace it back. The very first case that they identified, they didn't know why that child got sick, but there was an infant that ended up getting sick with cholera. And then they were disposing of the waste in their sewer system down below the house. And when they went down to go look, the walls of that sewer system weren't well maintained. And it was likely that that sewer water was seeping into the well water. Also, anecdotally, I'll just point out that there was one facility that did not have any contracted cases of cholera or any cases of cholera, and that was the brewery. And what was basically happening there when they went in, they were like, why don't you have any cholera? Where are you getting your water? And they're like, we're getting it from this pump. And they're like, well, what are you doing? And they're like, we're not drinking it. We're turning it into beer, and then we're drinking the beer. So that's one of the backstories there about trying to understand where these sources are and what potentially is happening within individual locations. It's interesting too, because John Snow is actually he didn't drink alcohol. And so, but if you go to this pump that you'll see here, this replica pump, that's a replica of the pump that existed back then in the 1800s. If you go to it, there's a pub right next to it, and the pub is called John Snow Pub. So I think it's kind of fascinating that we move forward 100 to 200 years into the future, and John Snow, who did not drink alcohol, has a pub named after him that's literally right next to um, the pump that made him kind of famous. But also, and just to kind of step back for a second too, we would probably not remember the story of John Snow if it wasn't for Reverend Whitehead, because Reverend Whitehead um, was able to carry on and talk about John Snow after he passed away. Unfortunately, John Snow, Dr. Snow, died at a young age. He died in his 40s. And that was before we discovered germ theory. And most of the medical establishment just brushed aside and kind of discredited his ideas around cholera being in water. He passed away. There was an Italian scientist that created a microscope, and one of the first organisms that they identified in water was cholera. And so then they were like, oh, it changed the way that we view germs. It changed the way that we view, our ability to understand water quality, etc. And John Snow was forgotten. But Reverend Whitehead carried on his story and told people, you're like, hey, you forgot about John. He was actually able to identify this and think of this linkage without actually even identifying what was in the water. And I think that in itself is like one of the most marvelous parts of this entire story, is that he was able to look at patterns to try to understand what was going on. And I mean, I think that's the true concept of genius at there to some extent, that you just are curious and creative in the way that you think, and critical thinking can get you to the source of many problems. And so to just kind of step back here for a second, I think there's a couple different takeaways from this story. One, we need to observe and understand patterns in our environment, especially when it comes to disease. You need to have local champions, because without Reverend Whitehead, not only would we have not understood the story of John Snow, but he probably wouldn't be able to get into that community the way that he did. And then public health challenges extend beyond the cause, determining the cause of an illness. Public health challenges are complex. John Snow and his colleague, they were able to take the pump handle off, but the community didn't have a second source of water. They didn't understand what was going on, so they protested and they put the pump handle back on. And that in itself is complex and sometimes even more difficult. And we still face these kind of problems today. But at the end of the day, perseverance is key. It's about continuing to try to understand, engage, and learn from our mistakes, and make sure that we're trying to continue to move forward to improving the health of the people that we serve. And so I'm going to talk about, we have a number of different challenges, and I'll just speak specifically to Nebraska here. There's everything from, we have these emerging contaminants like PFAS and microplastics that you might hear about. These are contaminants that can be in our water. You won't even see them. We have indoor air quality issues. We have arsenic in certain parts of the state of Nebraska that's just naturally occurring. We have manganese, which is also in certain parts of our state naturally occurring. Uranium, we find that in our groundwater and our drinking water. Industrial waste, there's a couple of different places that are more impacted than others. Lead, both within some of our older water systems, but also within homes that are older as well. And places like here in Omaha, where I'm at, we're actually inside a lead Superfund site. Socioeconomic factors, certain populations are more susceptible, are more at risk because they're in areas that are maybe potentially facing more of these environmental hazards. Nitrate, which I'm going to talk a little bit more about in particular, pesticides, which I'll talk a little bit about as well, radon, and outdoor air quality as well. There's just a variety of different factors that we face. But in this conversation, I'm going to talk more specifically just about water quality and the impacts that that has on human health. And so this has definitely gotten a lot of news and a lot of press recently. Um, over the last couple of years, there's been a number of different news stories that came out about water quality in Nebraska and in particular around nitrate, and which is excellent. Glad that this type of work is going on. But what I want to do is kind of just step back and just talk a little bit more about the problem at hand and some of the challenges that we face. And so when we talk about nitrate in drinking water in particular, sources of nitrate in drinking water come from nitrogen fertilizers, animal and human waste. Regulatory limit is set at 10 parts per million or 10 milligrams per liter. And I want to emphasize that because that 10 is going to come up on a couple different points as we move forward. And then the greatest areas of exposure are agricultural areas and individuals and private wells, because private wells are not regulated by the Safe Drinking Water Act. So it's up to the individual landowner or the person that owns that well to monitor that well. And this is a prediction of where we're facing nitrate issues in Nebraska. And so here in the red is where there's an estimate that it's above 10 milligrams per liter. And so you can see we have a lot of areas that are above the Safe Drinking Water Act. So this is just groundwater. And then we have a number of areas that are between 5 and 10, and a number of areas that are between 3 and 5. And then a good chunk of the middle of the state that's below 3. So couple things to know about this. Even though, these areas are above 10 and some areas are not above 10, it's just kind of focus in on some of those shifts, because these challenges we could potentially be facing more and more as we move forward. And so this gets at why and a lot of people are concerned about nitrate and human health. Regulatory limits, so that 10 was set for infant development of methemoglobinemia, which is otherwise known as blue baby syndrome, and it's not for other health outcomes. Numerous studies have found other relationships with nitrate and drinking water, and I'll talk about some of those in just as I move forward. And then high concentrations of nitrate in drinking water has been linked to adverse human health outcomes, whether it's blue baby syndrome, which blue baby syndrome is exactly what you think it is. It's a child will turn blue, and it's because of a lack of oxygen being able to transport through the body, because that nitrate will potentially inhibit the blood cells from combining with oxygen. And so again, that's why that regulatory limit is set at 10. But there's other links: minor health ailments, preterm birth issues, birth defects, pediatric cancers, and adult cancers. And so when I talk about cancer and how we can find the association between cancer and nitrate, this is the basic pathway here. So if I had a glass of water right now and that had a lot of nitrate present in it, and I drank that nitrate will mix with my bacteria that's in my mouth. And then when I drink it, it goes down, then that nitrate will turn into nitrite. And then when it goes down into mixes with my stomach acid, when that nitrite mixes with my stomach acid, it can then turn into an N-nitrosyl compound, which is also known as a NOC. And we know that those compounds are potentially cancer causing. And there's been a number of different animal studies that have shown if you expose animals with nitrate in their water, or potentially to those N-nitrosyl compounds, it will potentially lead to cancer, the development of cancer. Diet also seems to play a role. If you have a diet that's high in like red meat, or you smoke, that increases the risk if you have a diet that has a lot of antioxidants in it, so think of like green leafy vegetables, vitamin C, that decreases your risk of developing cancer with drinking water that's potentially contaminated with nitrate. And so when we're talking about adult health issues, increased rate of heart rate, nausea, headaches, abdominal cramps, cancers, colorectal, and I won't go through all of these, but at the time when this is put forward, there were 5 studies, 4 with a positive association, 1 with no association. Thyroid disease, there's been 3 positive cases. And then there's been studies that have shown an increased risk of thyroid cancer at above 5 milligrams per liter, so less than that 10 milligrams per liter that was set for uh, Safe Drinking Water Act standards. We have kidney cancer. There's been some work done there. Bladder cancer, non-Hodgkin lymphoma. Fewer studies have shown the relationship between non-Hodgkin lymphoma. There's also been some work looking at Alzheimer's, diabetes, and Parkinson's disease as well. Research around this, since we're close to Iowa, I wanted to throw up a couple studies here. Long-term ingestion of elevated nitrate in drinking water has been associated with an increase in risk of bladder cancer among postmenopausal women. They also found an increased risk of ovarian cancer in postmenopausal women as well. But this is one of the best studies. Just quickly mention that. There's a study that's in Iowa and also in North Carolina that's been looking at things like nitrate exposure and adverse human health outcomes. It's one of the most comprehensive studies that we have out there. Exposure to trihalomethanes, so these are like detergent type things, in drinking water is associated with risk of rectal cancer. Nitrate in drinking water was not associated with colon or rectal cancer. In this study, they also found a positive association with low dietary intake of nitrate from processed meat and stomach cancer. But they found no association with long-term exposure of nitrate to any of those digestive cancers. Health issues in children, multiple health issues have been identified. Like I said, the methemoglobinemia, especially for kids less than 6 months of age. And I just want to very quickly point this out where this comes from. It's drinking formula. Is if your child has a diet of formula and you're mixing it with water that's got high nitrate concentration in it. So that's why you have to kind of be careful and know what's going on inside that water that you're mixing in with formula, especially for children, because that's such a big component, less than 6 months of age, such a big component of their diet. Pediatric brain cancers, there's been some studies looking at that, non-Hodgkin lymphoma. And this kind of also talks about the complexity. There was one study that was done in Nebraska where they looked at non-Hodgkin lymphoma and found a 3-fold increase in risk when nitrates and atrazine were present. And so it wasn't just nitrate, but it's the fact that we live in a complex environment. We're getting multiple exposures at an individual time. Maternal and fetal health, CDC reported in 1996, there was a cluster of spontaneous abortions, otherwise known as miscarriages, in rural Indiana. They went out and did an epidemiological study, kind of similar to what John Snow did with that cholera outbreak. And when they went out and looked, one of the only commonalities that they found between those households was they were on private wells, and their well water was between 19 and 26 milligrams per liter. So very high concentration, well above the Safe Drinking Water Act standard. California has also done some studies looking at spontaneous preterm births. So these are births that don't come to full term, so that full 9-month period. And they found that with drinking water concentrations between 5 and 10 milligrams per liter. There's also studies that have shown the fetal growth restriction with exposure to nitrate. And we know a pathway for that to occur. So fetal hemoglobin is particularly susceptible to oxidation. So when the fetus is inside the parent, um, it is very susceptible to that blue, when it's outside and it's a baby, that's blue baby syndrome. We can find that the fetus is also potentially impacted by this as well. And so there was a study that showed that they found the met hemoglobin, so that's a hemoglobin that's impacted by um, uh, the lack of ability for the oxygen molecule to bind to the blood cells, which is what causes blue baby syndrome. So they found those met hemoglobin in the cord blood during pregnancy. And so it shows that there's a potential pathway for the fetus to be impacted in some way. Central nervous system malformation. So this is birth defects of the brain and spinal cord. 5 of 6 studies found a positive association with nitrate. 4 of those studies had concentrations less than 10 milligrams per liter, so less than the Safe Drinking Water Act. One of the things I want to point out here is that a lot of these are what we refer to as ecological studies. So they're more identifying correlation, but not necessarily causation. Causation's kind of difficult to sometimes determine in human populations because you can see patterns, but you might not necessarily be able to identify the mechanism that happens between that. I'm happy to talk about that more. So for being in public health, we always want to know which populations are most susceptible. For me, it's pregnant individuals and their fetus, young infants less than 6 months of age, children, anybody with an oxygen transport delivery issue, and then also anybody that's on a private well that has high concentrations of nitrate in their drinking water. I won't go into that. It just kind of talks about the complexity of all these different systems. But then now I'm going to step back for a second and talk about just some health issues that we face in Nebraska and even in Iowa as well. When you put Nebraska and Iowa together, they have 5 of the top 25 counties based off of incidence of cancer in the United States. So of the top 25 counties that has the highest incidence of cancer, Nebraska and Iowa have 5 of them. And then when we look at in the top 10, Nebraska and Iowa have 3 of those counties. So we have fairly high rates of just all cancer in this part of the world, part of the country. We also know that like in Nebraska, we have high rates of pediatric cancer. We have some of the highest rates of pediatric cancer in the United States by our state alone. And then also on top of it, we've been seeing increasing rates of pediatric cancer in Iowa and Nebraska. And so this is what this is showing here. So this is Nebraska, and our incidence, our rates of pediatric cancer have been increasing over time. And this is Iowa, and they've also been seeing increases as well. And so University of Nebraska Medical Center, this was a few years ago, did a study and looked at distribution of pediatric cancers. And one of the things that they found was it's not equal. Certain counties have higher rates than others, and that certain cancers in particular are higher than others as well. And so I've been part of some of these studies, some of my colleagues have been part of some of these studies where they found that areas where we have high rates of cancer is also areas, especially pediatric cancers, is where we have higher elevated atrazine and nitrate in the groundwater. Now, it doesn't mean that that's the potential cause, but it does mean that there's a potential relationship there. And so, we're continuing to try to research and understand some of these relationships, but we're also very concerned about what does this mean for potential impacts on our communities that we serve as well. For example, if somebody gets cancer in a household in the United States, especially in a place like Nebraska, the place where you get treated by, for example, pediatric cancer, it's in Omaha, typically. You might also travel outside the state of Nebraska. And so individuals can travel 8 hours, 3 hours, 5 hours. So a lot of times somebody in the household will move while that family member is seeking care. It becomes a financial burden as well, because now all of a sudden, if you're a dual income home, somebody is like traveling and trying to support the costs associated with that. And we also, we know in the United States, if somebody in your household gets cancer, you're twice as likely for that household to experience bankruptcy. And there's been some studies, for example, in Wisconsin that show that water quality associated with adverse human health outcomes has a lot of cost associated. There's a lot of cost associated with it, medical expenditures, and there's also a potential loss of productivity within the state as well. And so the goals for addressing water quality issues, identifying, we want to identify areas of risk and people that are potentially more at risk. We want to encourage those individuals to test their water, especially if they're in private wells. Find low cost, no cost solutions for them once they've identified this problem. And then make sure that we're maintaining these systems, both the water systems within the homes, but our water systems within Nebraska, to make sure we're reducing exposure and impact. And so I'm going to talk just a little bit about some of our engagement and outreach, because like I said, even though research is a big component of what we do, and we're looking at pediatric cancer, thyroid cancer, other adverse human health outcomes, and doing regional research efforts as well, we're also doing education. We're working on developing curriculum for students, for high school students, middle school students. We're interested in healthcare training, and I'll talk about that in a little bit. We're working through extension to make sure that people are out talking with the communities and understanding these potential threats so that people are testing more frequently. We're doing citizen science projects with the University of Nebraska-Lincoln College of Engineering. And then we're working with the state to try to help with improving understanding and providing resources across the state as well. So we're trying to tackle this from multiple different approaches. And, here's one example. We had an extension educator that worked with us for a number of years, trying to help with education around free water testing and providing systems on households to reduce potential impacts or reduce exposure, such as filtration systems. We're also very interested in trying to figure out how to better engage with broader populations around this. For me, in particular, healthcare professionals are incredibly important. I can't be in front of every person that's on a private well or in a potential area of risk, but I would imagine most of those people are talking with their healthcare provider. And if we can have an educated healthcare workforce, they can help with disseminating some of this information as well. But we found we have some challenges to face. We did a survey of healthcare providers across the state of Nebraska. Most of them said of healthcare providers, so doctors, nurses, etc. Most of them said that they're not knowledgeable about nitrate contamination in drinking water, and other large percentage said somewhat knowledgeable. So we don't have a lot of educated healthcare workforce around this issue, which is one of the biggest issues that we're facing as far as environmental contamination in the state of Nebraska. We also found that healthcare providers aren't very confident to talk to their patients about this. So there's more education that needs to happen. And then we're also interested in trying to make sure that the natural resource districts in Nebraska are very educated and understand this issue as well. And so we're trying to understand their level of understanding, but also trying to help improve that education outreach to them. And so we're working on developing things like this, which is education toolkits for public health professionals and healthcare providers. And like I said, we helped work with developing lessons for high school students so that they can understand these impacts and try to do something about it. And then not only that, but helping teach teachers around this concept so that they can be that advocate within their community as well. And so let's see if I can get it go. There we go. And so, yeah, it's a lot about being in the community, engaging, talking with various folks, and helping them understand these threats, and having some of these hard conversations. And so, opportunities moving forward, partnership to educate and do outreach. We want to work on trying to improve water testing, continue to do research in these issues, and create education materials for stakeholders. And so, with that, I want to thank our funders and our partners. And then if you're interested, don't hesitate to reach out and learn more about our program and some of the other great work that we're doing. And so with that, I'll wrap it up and I'll try to answer some of your questions.
Thank you so much, Jesse. We really appreciate you being here. We're going to go ahead. Sorry about that. We're going to go ahead and launch that survey. So if you guys could just take a minute to fill that out while Jesse's answering your questions, we would greatly appreciate that. And Jesse, are you able to see the questions on your end?
I am, yes. So, first question that was from Barbara. I hope I addressed it a little bit. I did talk a little bit about the nitrites issue and the nitrates and where that conversion is and why the nitrites is of even greater concern, because the nitrites is one step closer to that NOx compound that could potentially be cancer causing. And then I see the other question here, do contaminants tend to increase or decrease as groundwater levels decline, and why? And it depends on the contaminant. Some contaminants, as the groundwater levels decline, it actually causes them to consolidate, and you actually see higher concentrations. We've done some work in Iowa looking at groundwater changes around drought events and flooding events, and we found that for nitrate, heavier rainfall, flooding typically increases contamination of, or where you see higher nitrate concentrations. It's probably because more leaching. Droughts, we actually saw the opposite, where we saw a slight decrease. And that could be for a number of different reasons. But other contaminants, some of those you actually can see higher concentrations as that water resource kind of constrains. And I can't think of any right now off the top of my head, but I think it's arsenic maybe is that way, where you can see higher concentration of arsenic during drought events. No, it actually is. It was arsenic, where you see higher concentrations of them as the groundwater decreases, which arsenic is naturally occurring, but you see it in higher concentrations during drought events. At what ages does one need to worry about? Oh, it's moving on me. With about children and nitrates. I would say any age, for the fetus, it's definitely an area of concern. Ideally for me, if you're thinking about having children, or there's somebody that's pregnant, or thinking of getting pregnant, or you have small children, especially if you're on a private well, you probably should be testing your well, just see what the contamination is to make sure that you're reducing exposure. I think that's incredibly important. As far as blue baby is concerned, it's that less than 6 months of age, because a lot of times if they're on formula, especially, um, if the baby is drinking breast milk, that's not a concern. The body can regulate that, and so that's not a level of exposure. But if it is formula, that is an area of concern. And then any small child, I think, is of concern as well. Let's see. A lot of questions, a lot of good comments. I appreciate it. Yeah, it's been easy to get nitrate tests, but how do I test for atrazine? I have a private well in Holt County. So atrazine is more costly. Nitrate is typically much cheaper. The same place that you get your water tested for nitrate, you can ask for atrazine to be tested as well. And you can also get a more broader slew. And you can send that into a variety of different labs. I should have put that up there, but there's a number of different labs, both state labs and other labs, but you can also contact your NRD and they'll help you with some of those tests and identifying which tests that you might want to run for your private well. And so that's the best case scenario, is identifying your local natural resource district, contacting them and asking about what contaminants should they be, that you should be concerned about, and they can help you kind of guide through that process as well. And you can just, if you don't know your NRD, you can Google that, and they even have a nice little map, and you can identify where your NRD is. And there's a number of ways that they'll contact you, and they're great. Like, I've had such good fortune working with the NRDs. They're usually really helpful, and they want to help identifying some of these issues as well. Let's see, what are some of the other ones? Yeah, there's Renee said in here that Nitrate Watch through the Isaac Walton League will send you testing equipment and you can report your tests. Yeah, and we've got something similar with Shan Bartel Hunt at the College of Engineering. She has a citizen science project, so if you don't want to do like the big expensive testing, which honestly I think is the best case scenario, but if you just want to get testing done, you can get that water testing and go out and they little test strips and just see what your concentration is. And if it comes back high, then I would definitely get a more thorough test done as well. So where can I get your high school curriculum materials? Do you send speakers to schools and have projects with high school? Tiffany, yes. Let's see. So Taylor Hamlin is our person that's been working on that. I can try to drop his website in the chat, and where he posts all of his materials so that you can use those. I'll see if I can do that.
And if you want to send me an email with that, I will send a follow-up email probably next week that I can include that in it as well, just in case anybody misses it and wants to have that.
That would be excellent, because I can barely do one thing at a time, let alone two things at a time. So, but yeah, I would love to get you those materials, and also don't hesitate to reach out to me. I can also help get you those as well. Can you speak to all of the contamination of Ogallala Aquifer? A little bit. I mean, you know, we're certain areas where we're definitely seeing challenges within Nebraska. One of the things that, you know, we should be aware of, we're very fortunate in Nebraska because we have a lot of groundwater, and for the most part, it's really well managed as far as like the use. But we do have contamination issues, and those contamination issues vary by geography and soil type and depth of groundwater to the surface. And so there's a lot of different contamination. And then also on top of it, you know, I mentioned some of these other contaminants that we have. Nitrate is definitely an issue. It's a growing issue in certain parts of Nebraska. But we also have things like uranium that naturally occur within our groundwater system. We have, like I said, arsenic. And there's actually studies that have been done that shows that uranium, when nitrate is present in groundwater, it actually helps suspend the uranium, and so it makes it more available if you were to get water out of that groundwater. And we have a wonderful source of water for the state of Nebraska with that groundwater. Most of our communities in Nebraska are groundwater fed. Lincoln is a hybrid of groundwater and surface water. Omaha, I believe, is the only one that's purely surface water. So that's why we really have to make sure that we're protecting that groundwater, because it is such a valuable resource for our state. Are there effective filtration systems to minimize nitrate in water which is consumed? What is the best method? There's a couple different methods that you can use, for example, reverse osmosis systems. Um, and there's actually, and I don't know if any of the money is left, but there was actually funding available. So if you tested your well and you found out that you had concentrations that were high, you could apply to get a free testing system, or not free testing, a free filtration system to put on your household. And so there's two ways that you can potentially do it. You can do a much lower cost system that can go right underneath of your sink. And so for a single water source, especially if you use that for mostly for your drinking water. But then you can do a larger system. So that one's like a few $100. So it's still pricey, but not bad. You just have to make sure you maintain it and change the filter. But then you can do a much bigger system that's a reverse, like a reverse osmosis system for your entire house. And that's much pricier, thousands of dollars. But then all of your water is potentially filtered. And so if you do have some issues, the first step is testing it. And then if you see you have any issues, put those filtration. You can try to get one of those filtration systems. I would highly recommend that. Um, doo -doo -doo. Yeah. One thing about well water and nitrate, from what I understand, this takes 20 to 30 years to get to the groundwater, and farmers didn't necessarily do anything wrong. Yeah, 100%. I'm not trying to point the blame at farmers on this, and I always say that this is like a legacy issue for farmers as well, because they own these farms, they live on these private wells. The issues that they're facing is the issues that their children and grandchildren are going to be potentially facing as well, because a lot of times farming is a generational thing. And so it's handing it from one generation to the next. So by no means am I pointing the finger at the farmer around these issues. And there's a lot of farmers that are doing really good work right now to try to minimize their impact. Now, in some places, it's 20 to 30 years, and we're just going to continue to face this nitrate issue no matter what we do moving forward. Other places, it's a much shorter time frame, and so it's like 10 to 15 years, somewhere like that, because that surface to groundwater is much closer, and you'll see more potential contamination in those areas. What's the biggest obstacle in changing behavior? Oh, great question. I think it's just the education, outreach, having people understand, one, that individuals like me aren't here to try to demonize anybody. Um, and, at the end of the day, what we're trying to do is protect lives, reduce health impacts. And, if we get rid of nitrate, is it going to remove all cancer in Nebraska? No. But will it potentially reduce risk? Yes. And that's what we're most interested in, is reducing risk and trying to protect lives and stop situations that could potentially lead to something adverse. And so that's what we're really trying to do with this. Um, we've had great interaction with farmers, and I feel like the conversation has gone really far lately. And so I think we still need to continue to think about this and think about what are our challenges and how we need to move forward. But it's like getting everybody at the table and really talking and working together. How do you know if it's removing nitrate? Renee, that's a great question. Even if you have a system in place, and this is important, even if you have a system in place, you should still test it, because systems, if you have a reverse osmosis system, for example, still test the end to see if it's actually functional and it's working. The other part of it is if you have really high concentration of nitrate in your groundwater and your drinking water, systems aren't going to work fully and effectively. And so if it's too high, it can't keep up. So be aware of that. Is it okay to bathe and shower? Yeah, it's probably okay to bathe and shower in this. It's more about the ingestion itself that you should be worried about. How can natural resource districts? Uh, that's one of the big things. How do we get them more engaged on the research and community that they serve? That's one of the things we want to do is help with developing education tools and resources for natural resource districts because they've got enough on their plate. We want to be able to be that conduit or that advocate for them as well. Oh yeah, Amy said, great job there. Amy said you can also contact your health department for guidance on water testing. 100%. NRDs, local health department, and Amy's a great resource if you're interested. She's works at the local health department up in North Central. Um, Rising nitrate levels. Oh, bounced around on me. Okay, are rising nitrate levels a possible indication that more troubling contaminants are going to follow? Maybe. And honestly, that's a great point because we test for nitrate, but we don't test for a lot of these other things. And even if you test for atrazine, you're not testing for every pesticide available. So sometimes this can be the canary in the coal mine, as they like to say. And so it might be just identifying something, but it might not be telling you the full picture of what is going on. Um, and then Renee said, wait, where is the link for that? I don't know which link, but I'm happy to try to provide you a link as well. And I apologize, Renee. There's like so much bouncing around that it's hard for me to keep up. Oh, great. And Darcy said that there's funding allocated until 2028. That's wonderful. I wasn't sure when that was running out, so I love to hear that as well. And so I think I answered most of the questions, all the questions.
There's some that are in the Q&A. Can you see
Oh,
that as well?
okay. Well, I got one more question there. It was from Kay. Can you speak to the issue in Des Moines is experiencing as a result of high nitrate in the Raccoon River? I can't, unfortunately, and it's not because of lack of knowledge. I know some of the around it, but I'm not a huge, I don't know as much as I probably should. So I apologize there, Kay. I wish I could speak on it more. And then, okay, and then yeah, and then the open Q&A. Do you know of any studies that have looked at socioeconomic and demographic relationships to exposure with nitrate? Um, we've looked at Becky. That's a great question. Or was it? No, it wasn't Becky. Who wrote that? Oh, that was Barb. Wait, who wrote
That
that?
was
Sarah.
Sarah. Yep.
Sarah, that is a great question. We are doing a study right now on that particular issue. I can't think of anybody that's done that off the top of my head, but I'm sure that they have. So, um, within a year, I'm hoping that maybe we can be able to answer that question more effectively from some of the work that we're doing. But that's a great question. That's a really great question. But we are working on it. I know that, but I study right now, but that doesn't mean that it hasn't been done. If our city water is at the upper limit of nitrate level, is it just better to buy bottled water? Great question, Ann. I would say no. Um, Bottled water is a number of other challenges as well. One, bottled water isn't as regulated as your tap water is, and so it's actually um, uh, most safe to drink. More testing is typically done of your tap water than it is from bottled water. Plus, bottled water is in a bottle, a plastic bottle most of the time, and one that produce waste, which is problematic. But it also, some of the threats around microplastics become more of an issue in that regard. So it's better to drink your tap water, and if your city water is at that limit, that might be thinking about even putting another treatment on your tap as well. How can people get involved with helping? That's a great question, Becky. I think, engagement, having civil conversations with people to talk about this issue, just doing general education and outreach. If you know people, for example, that are on private wells, um, talking to them and making sure that they understand that this is an issue. And then being engaged in things like this, and then also making sure that you have a voice and talking with your decision makers, your policy makers around this issue as well. Because yeah, I think more that we have around people that can advocate for this, the better we are. Um, do you have any work with Native American tribes? For example, Santee Sioux tribe, northeast border of the state, has had undrinkable water due to high manganese for years. It looks like there was also orange in your map, blah, 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 close to the regulatory limit. Yeah, we've engaged. Yeah, yeah, that's a tricky one. That's a hard one. For those that aren't familiar, 100% read about and learn about what's going on with the Santee Sioux tribe up in northeast Nebraska. It's actually not too far away from where I grew up. Um, they have manganese that's likely not naturally occurring, and it's been shown to potentially have adverse human health outcomes, especially on childhood development. And it's in their drinking water. And so because of that, for years they've been having to ship water in, and they're trying to find solutions around that issue. But there's a number of other places as well that have been dealing with this manganese issue in the state of Nebraska, and it's a real challenge. I've engaged with the Santee Sioux tribe. I wish that there was more that we could do around that one, honestly. And then we've engaged with some of the other tribes as well, such as the Winnebago tribe around some of their issues. And then I see, did you say there is funding for osmosis units? If so, where can I find that? There is funding available, and where can you find that? Maybe with the follow-up email, we can send that out as well. But yeah, there's definitely. And then any other questions? I think we're a little bit over even. Ah, look, Darcy coming in with hitting the home run. Darcy put in the chat where you can find that reverse osmosis system tax credit act. So thank you, Darcy. I really appreciate that.
I am going to try to copy and paste it because it only went to the host and panelists. So give me 1 second.
And then, yeah, Amy said that you can also contact NRDs because some of them do cost sharing on that as well. So biggest takeaway is don't hesitate to reach out to get your well tested if you're on a well. If you have high concentration, you really think about getting some kind of system to filter your water. Don't hesitate to reach out to your local health department or your NRD if you have questions or information, because they can be potentially able to point you in the right direction or give you some good advice as well. And stay engaged.
And I did include that link in the chat, so everybody should be able to see that. And then it looks like there's just one more question from Cindy.
Oh, where's that one at? Oh yeah, Cindy, that's a good question. So that's how can we get the EPA to lower um, the limit for nitrate in drinking water? I heard that they were trying to reevaluate that limit. There's been a lot of good research that's been done to show that there are adverse health outcomes probably below that up until 5 milligrams per liter, which is below that 10, obviously. I don't know how that's moving forward, and it's a complex problem as well because and this is for anybody, you know, if you're even on a smaller municipal water system. For example, Omaha water system is very well maintained and regulated. If I get the tap water right now out of it, it's probably close to 0 for nitrate. And all of our water systems across the state of Nebraska are doing a good monitoring to make sure that things are falling within the safe and legal limits. Doesn't mean that things don't occasionally happen, but they're, I want you to be not walk away from here being like, oh no, I can't drink water anymore. No, we're very fortunate. Like, cholera outbreaks used to happen in places like Nebraska. We don't see cholera anymore. We don't see cholera in London anymore, and that's because of these systems that we have in place and our investment into our infrastructure within our country, um, which is wonderful. But it doesn't mean that like all potential threats are removed, and so it's about understanding what those potential threats are and being aware of them as well. And if we moved it down to 5, which I'm not saying we shouldn't, and I'm not saying we should. I'm saying we should definitely, but we should potentially think about it. Because that's a big conversation to have. But if we moved it down to 5, I'll say this, that I think there's probably a lot of systems in Nebraska that are struggling to get below 10. And that would be a large economic investment within our state. For example, Creighton, Nebraska, maybe you some are familiar with that. They have nitrate issues. They've put in a reverse osmosis system to try to reduce their nitrate concentration. And from my understanding, they still struggle to try to get it down to a low level. And so, and that system is millions of dollars to install and millions of dollars to maintain. And when we talk about dozens potentially, maybe more, maybe less, I don't know. I don't know the exact numbers on running that water or getting those systems in place and reducing that, it's going to be costly. And so we need to think about how do we actually implement that to make sure that we can afford those costs. And I'm not saying we shouldn't. I'm just saying it is going to be an economic investment, and we have to be willing to make a hard decision on being able to make that kind of investment. Because it kind of goes back to that pump handle, right? You can take the pump handle off, but you're not giving people a second source of water, like what happened with that John Snow story. So we need to make sure that we're providing people with fresh drinking water, but we do it in a way that doesn't make a huge economic burden to each of these small communities as well. And that's a challenging question, but a good one. And I'm not saying I really have a great answer for it by any means. But it's definitely something we need to continue to think about and work towards. All right, I appreciate it. I'm not sure how many people I put to sleep, but
Yes, thank you so much for this information. It was really great. And yeah, I think it gives a really good overview of some of the contaminants that we have and how that kind of affects things in our state.
thank you.
Okay, I just want to make sure there isn't. Okay. I just want to make sure there wasn't any more questions. So we are going to go ahead and end the webinar. Thank you everyone for attending. Thank you, Jesse, again. We appreciate it.
Thank you, everyone. I appreciate it. Have a good night.